Hi there. Today we're going to work out a question on coded mean from this book, the Statistics and Mechanics, and we have a question which is from the Cambridge examination. It says, Esme noted the test marks X of 16 people. So the number of people we have is 16 taking the test, and she found that the sum of X is equal to 824, and the standard deviation is equal to actually 6.5. Now we need to find the sum of X minus 50 and also the sum of X minus 50 all squared. Now, first of all, how are we going to find the sum of X minus 50? So we just need to open up this kind of notation here. So the first part, and I have sum of X minus 50, which you should know is sum of X minus 50 times 16 values. So minus 50 times n. So the sum of X been given 824. So we have 824 minus 50 times 16 turns out to be 800. So we have then 824 minus 800. So the answer is 24. So this is the sum of X minus 50. Now, we need the sum of X minus 50 to the square. So the way we do this is the sum of X minus 50 to the square. Let me just do it over here. So we're going to use the formula. We understand that the standard deviation has been given here. So what we are going to do is we're going to see the variance of so X minus 50 is going to be equal to the sum of X minus 50 to the square divided by n minus the sum of X minus 50 over n and all squared. So this variance of X, okay, minus 50 is actually 6.5 to the square because variance is squared. And we have then the sum of X minus 50 all squared divided by the number of values here is 16, okay, minus, this is the coded mean. And to find the coded mean, we take 24 here because that's coded with minus 50. So 24 over 16, all right, to the square. So 6.5 square, okay, is equal to sum of X minus 50 all squared over 16, and then minus 24 over 16 is actually 1.5, I suppose, because here with 24 divided by 16, so 4 goes in here, 6, 4 is here, 4, 6 over 4 is 3 over 2, which is 1.5. So this is 1.5 to the square. So now my summation of X minus 50 to the square is going to be equal to 6.5 to the square. This can come on the other side, plus 1.5 to the square, and then the 16, which is divided, gets multiplied by the whole expression. So we have the sum of X minus 50 to the square turns out to be 712. So here we are for the first part of the question, I would say. All right, and then so now we're going to move on to the second part of the question because I need a calculator. Just one moment, please. Okay, so here we go. We've got our calculator. Let's move on to the second part of the question. One person did the test later and her mark was 72. All right, so what we have is somebody did the test later. Now, the important information that I need from here, I'm sure you've copied that already, is sum of X minus 50, which is 24. And then I also need the sum of X minus 50 to the square. So I'm going to recopy that over here. So sum of X minus 50, we already worked out this value. and here we have sum of x minus 50 all squared 712. Great. Now in the second part of the question, we have a person who did the test later and her mark was 72. So mark is actually 72. So now the new value of n is going to be equal to 16 plus that person who comes into the group. So that's going to be 17. They're telling us to calculate the new mean and the standard deviation. Okay, to find the new mean, what we're going to do is we understand that the sum of x is 824. If the person's mark is 72, I'm going to take 72 add on to this. So what we're going to do is we're going to say 824 plus 72. So that's going to come to 896. So this is our new sum of x, which is actually now 896. So if I want to find the mean is the sum of x divided by n. So 896 over 17 now. So that's 896. Let's try and see. Divided by 17 turns out to be 52.705. Okay, so that's 52.705 and so on. So to one decimal place, I would say 52.7. That's the new mean. Is there another way of finding this new mean? So I'm kind of thinking here. Probably yes, or alternatively, maybe I could say sum of x minus 50, which is then 24, but that's the new one now. So the plus is going to add on to, because we're taking the 50 into consideration, and the mark was 72. So we're going to say 72 minus the 50 actually. So 72 minus 50 is going to be equal to 22, plus this is going to get 46. So we have the new summation of x. And so the coded mean is going to be equal to 46 divided by 17. So if I say 46 divided by 17, I'm going to get 2.705 and so on. So therefore the new mean is going to be equal to 50, all right, sent on the other side. So I'm going to say 50 plus the 2.705. So if we do so, we're going to get 52.705, which is exactly the same as this here. So that's going to be then 52.7 to three significant figures. That's the new mean. It's another way of finding the mean. And we need the standard deviation. So for standard deviation, we're going to be using the coded mean. So I need the new sum of x minus 50. The new sum of x minus 50, remember, to the square. The new sum of x minus 50. So what we're going to do, this old sum of x minus 50 to the square, is equal to 712. Add on to the new mark, which is 72 here. But take into consideration, this is coded by taking away 50 from it. So we're going to say 72 minus the 50, all of that to the square. So what we have is 712 plus 22 to the square. So let's do this. 712 plus 22 to the square, and I end up with 1196. So now I've got my new my new sum of x minus 50 to the square. So we can actually calculate the standard deviation. So for the standard deviation, I'm going to say it's going to be the square root of 1196. So let's put the formula. So that's sum of x minus 50 all squared divided by n minus sum of x minus 50, remember, over n. This is, remember, this is always the coded one. Coded mean. This part here is coded mean. So the standard deviation is going to be square root of summation of x minus 50 to the square was 1196 as calculated, divided now by 17 values minus the coded mean. The coded mean was actually 46 over 17. So 46 over 17 and square the coded mean. So let's do this on the calculator now. So divided by 17 and then minus in brackets 46 over 17 and all of that to the square, and I get 63 point something. So we are looking at the square root of 63 decimal 0.3111487. So let's take the square root of that. So the square root of what we just found here is now 7.939. So now the standard deviation is 7.9392 and the rest is kind of insignificant. So we have our standard deviation and turns out to be 7.94 to 2 decimal places or 3 significant figures. So here we are. I hope you've been able to make the most out of this. So this is a very interesting question on coded mean as set out by the C.I.E. exams. I guess the paper should have been, I think it's the October 2010 paper, component 970962, question number 3, if I remember correctly. So take care.